Welcome in our channel Informative Valley. Today our topic is most interesting and incredible. How Parker's solar probe didn't melt when it touched the sun. Parker Solar Probe made history as the first spacecraft to touch the surface of sun. Many people have wondered how the probe was able to withstand temperatures of up to 2,500 degrees Celsius without melting. The answer lies in the design of the probe and the materials used to construct it. Here we will explore why Parker's solar probe did not melt when it touched the sun. We will look at the engineering behind the probe and how its materials were able to withstand the extreme heat and pressure of the sun. The science of why Parker's solar probe didn't melt when it touched the sun. The Parker Solar Probe is the first ever spacecraft to fly directly through the atmosphere of Sun. It has been traveling towards the Sun since 2018, and made its closest approach in 2020. But how is it possible for a spacecraft to survive such extreme conditions? The answer lies in the probe's heat shield, which was specially designed to protect the spacecraft from the intense temperatures near the Sun. This shield is made of a special carbon composite material that can withstand temperatures up to 2,500 degrees Fahrenheit, 1,371 degrees Celsius. This heat shield is only 4.5 inches, 11.43 centimeters thick, but it is enough to protect the spacecraft from the extreme heat. The spacecraft is also equipped with special thrusters which allow it to reach speeds of 430,000 miles per hour, 692,000 kilometers per hour. This high speed helps it travel quickly through the sun's atmosphere, and also helps to keep it cool. These two components, the heat shield and the thrusters combined, allow the Parker Solar Probe to survive its close encounters with the sun and collect data from within the corona. With this data, scientists hope to gain new insights into how the sun works and how it affects Earth's climate and environment. The Parker Solar Probe has already made several close approaches to the sun and will continue to do so until 2025. So far, it has collected data on solar winds and other features of the atmosphere of Sun, and will continue to do so over the next 5 years. The success of the Parker Solar Probe has opened up possibilities for future exploration of the Sun and other stars. In the future, scientists hope to send probes even closer to the Sun, further improving our understanding of the star at its heart. The technology that allowed Parker's solar probe to withstand the heat of the sun. The Parker Solar Probe has been able to survive the extreme temperatures of the sun due to a special heat shield. This heat shield or thermal protection system, TPS, is made up of two separate layers of reinforced carbon composite which provide maximum protection from the heat of sun. The outer layer is specifically designed to deflect the heat of sun and radiation away from the spacecraft, while the inner layer is able to absorb and dissipate the remaining heat. This heat shield has enabled the Parker Solar Probe to fly within 4 million miles of the surface of Sun, at speeds of up to 430,000 miles per hour. This means that the Parker Solar Probe can complete an orbit of the Sun in just 88 days. The Parker Solar Probe is also equipped with various instruments and cameras which allow it to send back data and images of the Sun. Thanks to its cutting-edge technology, the Parker Solar Probe has been able to study the atmosphere of Sun more closely than ever before. It has sent back images and data which have shed light on some of the Sun's most mysterious phenomena such as solar flares, coronal mass ejections, and other solar events. The data collected by the probe has also helped scientists to better understand how the Sun affects space weather, and how this can impact Earth. Scientists now have a greater understanding of how to safely explore our own star and are looking ahead to see what new discoveries lie ahead. With its successful mission, the Parkar Solar Probe has set the stage for exciting advances in space exploration in the years to come. The implications of Parkar's solar probe for future space exploration. The Parkar Solar Probe has opened up a world of possibilities for space exploration and has set a precedent for future space missions. The heat shield that protected it from the sun's immense heat and radiation allowed it to get closer to the sun than any other man-made spacecraft before it. It has sent back incredible images and data about the sun's atmosphere and will continue to provide us with important insights into our closest star. The Parkar Solar Probe has been able to reach speeds of up to 430,000 miles per hour and can make one complete orbit around the sun in just 88 days. This incredible speed allows it to capture valuable images and data much faster than ever before. With its revolutionary design and technological advances, the Parkar Solar Probe provides an example of what is possible in space exploration. The Parkar Solar Probe mission has also raised questions about future space missions. For example, how close can a spacecraft get to the sun? What kind of technology will be needed to get even closer? Will the Parkar Solar Probe eventually crash into the sun? How will future space missions be able to use the data collected by the Parkar Solar Probe? The Parkar Solar Probe has set a new standard for space exploration and has provided us with unprecedented insight into our closest star. With the data gathered by this revolutionary mission, we are sure to see further advances in our understanding of the sun and its environment. Future expectations are high for the Parkar Solar Probe, and it will certainly be an exciting journey as we explore our star even further. Thanks for watching.